Hello everybody, myself Nidhi Joshi, and in today's session I am going to discuss about minimum spanning tree, as well as I am going to discuss about the Prim's algorithm. So in my session I will be discussing minimum spanning tree, that is one of the application of the greedy method, as well as in the minimum spanning tree, like how to find the minimum spanning tree. For this reason we can use Prim's algorithm and Kruskal algorithm. So in my session firstly I am discussing Prim's algorithm, and this Kruskal algorithm I will be covering in my next video lecture. So before starting what is a Prim's algorithm, let us first understand what is a minimum spanning tree. A minimum spanning tree is a special kind of tree that minimizes the length or weight of the edges of tree. Let us consider a simple example of the cable company. The main objective of the cable company is to provide facilities to all the customer, but with the minimum cable cost. So if I am technically talking about what is a spanning tree, a spanning tree of a graph is a subgraph which is basically a tree, and it contains all the vertices of graph containing no circuit. The circuit should not be there. All the edges of the graph should be there, but with the minimum cost. Now let us see what is a minimum spanning tree. Minimum spanning tree is a spanning tree with the minimum or the smallest weight. The weight should be minimum or it's having a smallest weight. Now let us see what is the weight of the tree. The weight of the tree is the sum of all the weights of all its edges. Suppose we are having one graph. So let us consider this as the node A, B, C and D node we are considering. This is the node and this is the edge. Suppose 2 is the weight, 3, 5, 4, 7. So this value 2 is representing the weight of an edge connecting the node A and B. Now we'll see some of the application of spanning tree, like where we are using the spanning tree. We are going to use it for the efficient routing algorithm. We can use it for the network design. We can use it for the cluster analysis. Now, as I was starting this lecture, I had discussed, like in my session particularly I am discussing what is a minimum spanning tree and how to find the minimum spanning tree. For this reason we are using two algorithms. First is the Prim's algorithm and second one is the Kruskal algorithm. So first we'll see what is a Prim's algorithm and how we can find the minimum spanning tree with the help of the Prim's algorithm. So the Prim's algorithm is a minimum spanning tree algorithm that takes the graph as input and find the subset of the edges of the graph, which includes all the vertices which are there in the graph, or which include every vertices of that graph, as well as the graph has the minimum sum of weight among all the trees. Or in a simple word, the graph contain all the vertices with the minimum sum of weight. So we'll see how Prim's algorithm work. Here in the Prim's algorithm, what we are doing, first we are starting from one vertices and selecting an edge with the minimum weight. So first what we are doing, we are starting from one vertices of the graph, and then we are selecting an edge with the minimum weight. We are continuing or proceed this algorithm by selecting an adjacent edge with the minimum weight. The edge should be adjacent and should be minimum. Here in the Prim's algorithm, one care should be taken into consideration, which is that no circuit should be formed while choosing the adjacent edge. To understand this algorithm, how this algorithm works, let us consider one example. Like here we are having one weighted graph. Weighted graph, the edges are having some weight. So in the previous slide I had discussed like we have to start from the one point. Here we are starting from this point. If it is not specified in the question, choose one starting point. Here we have to consider all the vertices first. We have to select an edge with the minimum weight. So here my next step is to select the edge with the minimum weight. So I am starting from this point and I am choosing the edge with the minimum weight. Here the minimum weight is 2. After choosing the minimum weight, the next minimum weight I had chosen is 2. After that I can choose the minimum weight edge. Like here the minimum weight edge 2 is over. Now we have to look for the minimum weight edge is 3. So I can choose this one, this one. If I am choosing this edge also, although it is having the minimum weight of 3, here it is going to form the circuit. I cannot choose this edge furthermore. So the adjacent edge of the weight 3 is completed, is done. I cannot choose the adjacent edge having a minimum weight of 3. So I have to choose the adjacent edge of having weight 4. So here I can choose this one, this one, this one, or this one. So I have to look for that vertices which are already covered. So this vertices I had covered, this vertices we had already covered. So we are not choosing this edge. We can go for this edge or this edge, any one of the edge. So for my convenience I am choosing this edge, this edge. So generally like if we are having we have to choose among the edges. So if the number is given, we'll go in the increasing order number. If we are having the alphabetical the nodes are having are in the alphabetical order, then that time we'll choose the edge in an alphabetical order for our convenience. So here if we are seeing, like we have chosen, we had started from this point, that point I had covered, we were proceeding like this. So we have chosen this one, this one, this one and this one. So here at the last we got the graph having all the vertices, all the nodes or vertex, this vertex, this one, this one, this one, this one and this one. So here what we got, in a simple word, we got the minimum spanning tree. Minimum spanning tree is a tree which contain all the vertices of a graph without the circuit, or having a minimum or the smallest weight. If I am calculating the weight of this graph, the weight is 2 plus 2 plus 3 plus 3 plus 4. So this one, this one, this one, this one and this. So this is the weight, this is the total weight of the graph, and which is minimum. Total weight here is 14. So here we got the minimum spanning tree. So in my session I had discussed about what is the spanning tree, minimum spanning tree, and in order to find the spanning tree, minimum spanning tree, we are using Prim's algorithm. For the Prim's algorithm, we are starting from one vertices and choosing the edge which is adjacent, choosing the minimum weight edge which is adjacent. And how the algorithm is proceeding, we had understand the concept with one example. I hope you are getting how Prim's algorithm is working. That all is there in today's session. In case if you are having any queries related to Prim's algorithm, just let me know. Thank you.